Let's talk about systems of equations. So on the left here, I have a system of two equations. There's two equations and two unknowns because I have an unknown x and I have an unknown y, and there's two of them. And what that means is they both need to be satisfied at the same time, versus if you had instead over here on the right just x plus 7 is equal to 4. That's one equation and one unknown. It's not a system. There's just one of them. Solutions to these um, when they're by themselves, just one equation and one unknown is just, well, x is equal to, looks like -3 in this case. Versus a system, there has to be an x that has a friend y that go together that satisfy both equations simultaneously. So let's take a look at that system that I have up, and let's see determine if the following are solutions or not. Now we get an idea of what these solutions look like. So the first one I'm going to go for is, let's go with 4, -4. And so you can see that I have an ordered pair. It always goes alphabetical unless otherwise specified. So what we're saying here is x is equal to 4 and y is equal to -4. That combination is a solution. So let's check it out. So the first equation is x plus y. So I'm going to plug in 4 for x and -4 for y. And you can see that gives me 0 because it's a 4 minus 4 is 0, which is exactly what I want because I have that on the right side. So it satisfies the first equation. That's not enough. It's got to satisfy the second one also. So let's check out x squared plus y squared. So x squared will be a 4 squared plus a y squared is a -4 squared, which is a 16 plus 16. That's 32. That's exactly what I wanted. So it satisfies both of them. So this 4, -4 is a solution to that system because it satisfies both of those equations simultaneously. Second one, let's check out. How about 1, 2? So that means x is equal to 1 and y is equal to 2. So if I plug it into the first equation, x plus y, I get a 1 plus 2. That's 3. Well, that's not what I wanted. I wanted 0. So it does not satisfy the first equation, so it is not a solution to the system. I don't even have to check the second one because the solution has to satisfy all of them. If you don't satisfy one of them, you are not a solution. So that's the idea behind systems. We're looking for, if we have two equations and two unknowns, I have an x and a y, my solutions are going to look like ordered pairs x comma y. The ones that we're going to focus on in this section, because this section is all about nonlinear systems. Nonlinear systems means that one that I had up, just so you can see it again, x plus y is equal to 0, and x squared plus y squared is equal to 32 is nonlinear because you can see on at least one of my variables, I have an exponent other than 1. So I got a squared here and I got a squared here. Those make it non-linear. A linear system would look something like, 3x plus 4y is equal to 8, and then -x plus 7y is equal to 15. You can see over here that I only have 1s for the exponents, so that would be a linear system. But we're focusing on nonlinear in this section. We're going to look at a couple different types of them. This first one, here, it's a little easier to tell if you solve for y, that would be y is equal to -x, that's a line. And this x squared plus y squared is equal to 32, that's a circle. So essentially what we're looking for is, well, where does this line intersect the circle? Because if they're intersecting, that means it's on the line and it's on the circle. So if I draw myself a little picture here, that circle, x squared plus y squared is equal to 32. That's centered at 0, and it's got a radius of square root of 32, which is somewhere between 5 and 6. 5 squared is 25 and 6 squared is 36. Ooh, not the best circle I've drawn, but we'll go with it. And then the line, y is equal to -x, intercept 0, slope -1. So what we're looking for would be these intersections right here. Because if you're on the intersection, it means you're on the blue line, which means you satisfy the first equation. And if you're on the red circle, I swear that's a circle, then that means you're satisfying the second equation. So where those two intersect means you satisfy both equations. That's what we want. So here's one type that we're going to look at in this section. We're going to look at intersections of lines and circles. We're also going to look at lines and parabolas, which visually an example of that would be if you had, say, here's a parabola, and then here's a line. Woo. So on that one, you could have, say, two solutions, or you could have one solution, or you could have no solutions would be an option. And then the other one, let's see, parabola and circle is the last one I haven't written down, and those are the three that we're going to talk about. So parabola and circle, circle red. and parabola blue. Okay, so those are the types that we're going to talk about, and again, they are non-linear because they have an exponent other than 1 on there, and that's what systems are in general, and in the next video we'll talk a lot more about how to solve them.